Well, howdy, folks, and let us continue with our discussion of the mole. Yes, if I can get this thing down. There we go. So we're talking about the mole, and let us go back and take a look at our definition, right? We're talking about the mole. We said that the mole is a measure of quantity, and that the real definition I want you to know is this one, that the mole is Avogadro's number of particles. Good. And then we started doing some calculations with the mole, right? And we probably are going to need some more space, so let's go. Let's extend the page. And you may not have known it, but we were doing a calculation where we were going from moles to what? We're going from moles to particles, right? And we said, hey, particles can be atoms, particles can be ions, particles can be molecules, particles can be formula units, right? Formula units. And I work these all using dimensional analysis. But if you don't like dimensional analysis, here's the way that you can go from particles to moles, right? To go from moles to particles. To go from moles to particles, what did we do? We multiplied by AVO. Okay, so if you take moles, multiply it by AVO's number, then you're going to get particles. All right, cool. That's our first calculation, moles to particles. Now, let us take a look at this one. Beautiful color, right? Consider 9.78 times 10 to the 25th ions of fluoride. How many moles? So I'm going from ions to moles, okay? Well, that's another calculation. What are ions? Ions are what? Ions are a particle. So how am I going to go from particles to moles? Okay. If I go from moles to particles by multiplying by avos, how do you suppose I go from particles to moles? I'm going to divide by avos number. Okay, so that is the process. I don't use that process. I use dimensional analysis, right? Because I know that 1 mole is equal to what? 6.022 times 10 to the 23rd ions, right? And I start with 9.78 times 10 to the 25th ions. I'm going to multiply that by a fraction. I'm going to put on top what I want. What do I want? I want moles. So I'm going to put 1 mole of what? Fluoride. So I have 1 mole of fluoride ions. And I'm going to put what I want to get rid of, 6.022 times 10 to the 23rd fluoride ions, right? Fluoride ions. Good. So my ions, this is what fluoride ions, my fluoride ions cancel and I'm left with moles. So that's the way I do it. Here we go. 9.78 times 10 to the 25th divided by 6.022 times 10 to the 23rd. And I get 162. 3 sig figs. So let's see, I have 4 sigs here, and I have 3 there. I can only have 3 here. So my answer is 162 what? Moles of fluoride. Woohoo! There we go. Cool. All right, you guys give this one a shot. Bring me back when you're ready. Well, I have molecules. Molecules are particles, and what do I want? Moles. So I want to go from molecules to moles. To go from molecules to moles, I have to divide by AVO. So if you're using just formulas, use that. Of course, I'm not a formula guy. I am a dimensional analysis kind of guy. So I take 5.178 times 10 to the 24th, what? Molecules of dinitrogen pentoxide. And I'm going to multiply that by a fraction. And what's going to go on top? I have, what's my equality? I have 1 mole of dinitrogen pentoxide is equal to 6.022 times 10 to the 23rd, what? Molecules of dinitrogen pentoxide. Cool. All right. What do I want to get rid of? I want to get rid of molecules, so I'm going to put this thing right here into my denominator, 6.022 times 10 to the 23rd molecules, because I want them to cancel each other out. Molecules of dinitrogen pentoxide, which means what has to go on the top? 1 mole of dinitrogen pentoxide. My molecules cancel. I'm left with moles. That's exactly what I'm seeking. So I take what? 5.178 times 10 to the 24th divided by 6.022 times 10 to the 23rd, and I get 8.5984, right? But how many sig figs? I have 4 sigs. Well, let's look at I have 4 sigs here, and I have 4 there, meaning I can have 4 here. So I have to truncate that, and I have 8.598. What? What are my units? Moles of dinitrogen pentoxide. Hee hee! Winner, winner, chicken dinner. All right, you guys give this one a shot. Wait a minute, that looks the same. We don't have to give that one a shot. We've already done it. Good. Moving on. Consider, this color. Consider 84.67 grams of gold. How many moles of gold? Okay, so what am I doing? I'm going from grams to moles. Do we know how to go from grams to moles? Is grams a particle? Well, I don't quite remember. Let's see. What are my particles? Oops, that's not where I'm going. What are my particles? Yoink, yoink, there we go. What are my particles? Particles are atoms, ions, molecules, formula units. Are grams there? No, grams are not particles. So that means we have another another equation. If I'm going from grams to moles, okay, grams to moles, what am I going to do? I'm going to divide by something called mm. And what is mm? Mm is molar mass. Okay, and what's molar mass? Well, the molar mass is defined as what? The mass of 1 mole of something, of an element, of an element, of compound, of whatever's given. It's the mass of 1 mole. Good. So I'm going to take grams and divide by the molar mass for whatever I'm looking for, and that'll give me moles. Cool. So let's go back to our questions. Yikes, we need to go farther, don't we? We're here. What do I have? Okay, I want to go from grams of gold. I want grams of gold, and I want to, excuse me, I start off with grams of gold, 84.67 grams of gold, and I want to find out what? Moles of gold. And so I need some kind of equality, and we said that what? Molar mass is equal to the mass of 1 mole. So that means 1 mole of gold has a mass of so many grams, right? And how do I figure that out? Well, we use the periodic table. Okay, here's the cool thing. See these little numbers here? Right there. Oops, you can't read that now. Let's look at zinc. See zinc? It says 65.39. Well, that's the molar mass of zinc. My average atomic mass of an atom equals the molar mass of that atom. Okay? So we're looking at gold. Where's gold? Where's gold? Here's gold, and my average atomic mass is 196.966. Well, that is my molar mass. And the thing about it is these units are in grams per mole when we're talking about molar mass. So that means the molar mass of gold, Au, is equal to 196.966 grams of gold per mole of gold. All right, we can do our problem. 196.966. 196.966 grams of gold. Now that's probably more sig figs than we need, but here we go. Are you ready? Let's rewrite this. I have 84.67 grams of gold. I'm going to do this the dimensional analysis way, right? I'm going to take what? What is it that I want? 1 mole of gold over what? 196.966 grams of gold. All right, good. And what's my answer? I get 84.67 times 1 divided by 196.966, and I get 0 0.4, how many sig figs? 4 sig figs here. 0.4299, what are my units? Moles of gold. Okay, there we go. Now, if you're not into dimensional analysis, you just want to follow the formula, we take grams, divide it by the molar mass, and that'll give our moles. So we have what? 84.67 grams of gold divided by what? 196.966 grams per mole. And what's that equal to? My grams cancel. I have 1 over 1 over moles, and I get 0.4299 moles of gold. There we go. So either way will work. All right, you guys give this one a shot. Bring me back when you're ready. Well, I'm going from grams to what? Moles. So I need an equality between grams and moles. We know that's my molar mass, right? I look on my periodic table. Where's magnesium? Here's magnesium. So it's what? 24.305. 24.305. So I have 24.305 grams of magnesium equal 1 mole of magnesium. Or you could have thought of it 24.305 grams per mole of magnesium, right? Either way, this is my molar mass of magnesium. This is the equality, and I'm going to turn that equality in a second into a fraction, right? 16.752 grams of magnesium. Remember, I write all of my units. I'm going to multiply that by what? Well, I want to get rid of magnesium grams, so I'm going to write that in the bottom, 24.305 grams of magnesium, and that means this has to come here, 1 mole of magnesium. Cool. So what do? I take 16.752 divided by 24.305, and I get 0.68. How many sig figs? Ooh, I get 1, 2, 3, 4, 5 here, and I have 1, 2, 3, 4, 5. I have to have 5 sig figs. Holy cow. 0.68924. What? What are my units? What are my units? Grams of magnesium cancel. What am I left with? Moles of magnesium. Yoo-hoo! 0.68924 moles of magnesium. Excellent. All right. This is a little harder now, right? Because before we were only talking about molar mass, right? And molar mass of atoms. Now what do we have here? Well, this is what? That is an ionic compound. How do I figure out the molar mass of a compound? Okay, maybe we should put in some notes here on molar mass. What do you say? Okay, calculations. Somewhere under calculations, put over here molar mass. Molar mass, right? And we said that that is the mass of 1 mole of stuff. And now if I have atoms, right, then it is equal to for an atom, the molar mass equals the average atomic weight, right? Good. What about if I have a compound? What does that equal to? Well, for a compound, we are going to take the summation, it's probably 2 m's there, of each atom molar mass in compound. So that means I'm going to, if I have If I have something like H2O, that means I'm going to take 2 times the molar mass of hydrogen, 2 times the molar mass of hydrogen, plus 1 times the molar mass of oxygen. Okay? Good. So that's what we're going to do. Now, let's do that with our specific question here. I have barium chloride. That means the molar mass for barium chloride is going to be equal to what? 1 times the molar mass of barium plus 2 times the molar mass of chlorine. Got it? So where do we find those? On the periodic table. What is barium? Let's clean this up a bit. Zoink! Abracadabra. Woo! What? Abracadabra. Let's try that again. Yay! Just like magic. Barium. Where's barium? Barium is right here. Looks like it's 137.32. 137.32. 137.32 plus 2 times, what's my chlorine? Let's go to chlorine. Chlorine is 35.45. 35.45. 35.45. 35.45. Good. And what are these units here? Grams per mole are the units. So here, let's do it. 35.45 times 2. Got it? Plus 137.32. What do I get out of that? I get 208.22 grams of barium chloride per mole of barium chloride. Excellent. There we go. Hey, this is easy. All right, you guys do aluminum fluoride? Bring me back. Well, the key to doing aluminum fluoride is making sure we understand how to write the formula. Aluminum, when it forms an ion, forms a +3 cation. Fluoride forms a -1. So that means if I have a +3 and a -1, my least common multiple is 3. How many aluminums do I need? I need 1. How many fluorides? 3. So AlF. So the molar mass of AlF3 is equal to 1 times the molar mass of aluminum plus 3 times the molar mass of fluorine. Got it? So we go to our periodic table. Aluminum is 26.98. Usually I go with 2 decimals, but you just don't want your number here to limit your sig figs. So you always use as many numbers here as you have in your given. I tend to go with 2 decimals because that usually is sufficient. 26.98, 26.98, and we'll understand more of that later. Times 3 times my fluorine. Where's my fluorine? Oops, get rid of that. It looks like it is 18.99. You guys buy that 18.99? 18.998, I think that is. We better go with one more sig fig since it's, well, that would mean what? I'd have to round it. 18.998. That's fine. 18.998. 18.998. Good. And what do we get here? Now, you guys will learn something here in a second. Times 3 plus 26.98, and I get 83.97. Now, notice I can only have sig figs to the hundredths, so I've got to stop right there. Good. And that is what? Grams of aluminum fluoride per mole of aluminum fluoride. Good. Excuse me. Now, what I wanted to say is your number may be slightly different than mine if you're using a different periodic table or if you're choosing more or less sig. Yikes, sorry there, folks. Or if you're using more or less sig figs. Got it? So if you're around 83.97, that's close enough. All right, you guys do this one. Bring me back when you're ready. Our chromium 2 phosphate, EGADS. Well, chromium 2, what does the 2 mean? Well, that means my chromium has a charge of 2+. Phosphate, ooh, I hope I memorized my polyatomics. I did. I have 2 and 3. My least common multiple is 6. So how many chromiums do I need? I need 3 chromiums. How many phosphates do I need? I need 2 phosphates. Wow. Okay, so what's the molar mass of my chromium 2 phosphate? Well, we have to be careful here. How many chromiums do I have? Well, I have 3 chromiums. So I have 3 times the molar mass of chromium, right? Cool. Plus, well, how many phosphates do I have? Well, this says what? I have 2 phosphates, so how many phosphoruses do I have? 2 times the molar mass of phosphorus.
Hey there, teachers. Just a note that the sitting chart.
Sorry, doesn't that annoy you when you're in the middle of something and then they bring in an announcement? Yeah, that annoys me. Well, let's move on. So where were we? Well, we were trying to figure out my molar masses and how many oxygens do I have here? Well, I have 2 phosphates and each phosphate is PO4. So how many oxygens do I really have? I really have 8 oxygen atoms. Good. So that means to get my molar mass of chromium 2 phosphate, I need to get 3 chromiums, 2 phosphoruses, and 8 oxygens. Let us do that. Let's go to the periodic table. Where are my chromiums? Chromium, chromium, chromium. How about 51.996? Okay, 51.996. 51.996 plus 2 times, what's my phosphorus? Come on, phosphorus, bring me phosphorus. Where's phosphorus? How about 30.97? 30.97. 30.97 plus 8 times oxygen. 8 times oxygen. Oxygen, oxygen, oxygen. Can't even see oxygen. Oxygen. 15.999. You know what I use instead of 15.999? I use what? 16.00. I round that, and that's in what? Grams per mole. Good. So here we go. And I'm going to be limited to what? Hundredths in my units. So I take 3 times 51.996 plus 2 times 30.97 plus 8 times 16. And I get 345.928. But I can only be significant here to my hundredths. So 0.93 grams per mole. There we go. And like I say, your number may be slightly different than mine, depending on how many sig figs you used and what periodic table you used. All right, here we go. I'll tell you what, let's come back here next time. We're already 23 minutes into it. Let's stop here and we'll come back and finish next time.